Every screwdriver and chisel has to have a handle. This factory makes handles from acetate, a synthetic resin. These acetate bars are 6 feet long and come in many colors and contours. They arrive here ready-made. Workers load the bars onto a machine that feeds them into a lathe. As the lathe spins, an automated knife cuts one handle after another, rounding off what will be the top of the handle. Then it sculpts the other end. Then a drill makes the hole into which they'll later insert the blade. All this takes just a few seconds. Now the handles travel to their next stop, the dipping machine. Acetate becomes dull and opaque when it's cut, so the machine dips them in acetone, a chemical solvent. This brings back their translucence and shine. It also removes any acetate shaving stuck to the ends. Here's what the handles look like before the acetone bath. And here's what they look like after. The handles air dry on their way to the next stop on the production line, printing. The hot stamp printer works in conjunction with an ink ribbon. It applies about 55 pounds of pressure, engraving the product code and brand name, while the heat, about 160 degrees Fahrenheit, transfers the ink from the ribbon into the engraved lettering. The handles are finished, and it's finally time to insert the blades. In this case, Phillips head screwdriver blades. Blades are made of carbon steel. An automated machine forces them into the handle with about 80 pounds of pressure. Workers insert chisel blades manually in order to protect their sharp edge. At the same time, they top the handle with a steel cap to give the chisel extra striking power. Another common hand tool is the drywall square, also known as a T-square. They cut 2 strips of aluminum, the first 4.5 feet long, the second 22 inches long. Then they apply the markings by silkscreen printing. Next, they use a bending machine to hold over the top edge of the piece that will form the horizontal part of the T. This will allow the tool to hook onto the edge of a drywall panel. Finally, they rivet the 2 pieces together. The drywall square is finished. Factories can alter the size of the tools they produce to meet their clients' specifications. Standard screwdrivers have handles measuring 3.5 to just over 4 inches long, with blades that are 1.5 to almost 8 inches in length. Some screwdrivers, on the other hand, have extra long blades, while stubby screwdrivers have short handles for getting into tight places. Then there are those skinny pocket screwdrivers and precision screwdrivers for jewelers and electronic technicians. All of which proves there's a tool that's the right size for every job. We use them to apply and blend our makeup. We use them in a pinch to pry dirt out of tight crevices. And of course, we use them to clean our ears, though doctors say never to insert them into the ear canal. Cotton swabs are just one of those little things that are really handy to have around the house. Cotton swabs were invented in 1926 by Leo Gerstenzang, a Polish-born American. He got the idea from watching his wife clean out their baby's ears using a flimsy toothpick stuck into a piece of cotton. Leo set out to design a safer device. He took a thicker wooden stick, wrapped the ends with cotton in such a way that it wouldn't come off and get stuck in the ear. The Leo Gerstenzang Infant Novelty Company marketed this invention under the trade name Baby Gaze. Many cotton swab makers also produce cosmetic pads. Both start with bleached cotton. It arrives at the factory compressed in large bales. The cotton first goes into a machine called the feeder. From there into a machine called the opener, which shreds the bales, pulling the cotton fibers apart. Next stop, the carding machine. Its large rollers comb the cotton fibers out. Then, guided by weight-detecting sensors, it produces a uniformly thick ribbon of cotton called a web. This web is now ready to be processed into either cotton swabs or cosmetic pads. To make pads, they layer several webs. Just how many, though, is a closely guarded company secret. And so is how much pressure they apply to those layers to compress them. This secret recipe of layers and pressure is what ultimately determines the weight of the pad. The heavier it is, the higher the quality because it's thicker. The now compressed layers of web go through a machine called the slitter. It cuts the wide roll into several narrower rolls called header rolls. Each header roll then goes through a machine that stamps on a quilt-like pattern, purely for aesthetics. Finally, using a punching die, they cut the pads. On this production run, each pad weighs about 0.02 of an ounce, but the factory can produce whatever weight the client requests. The cosmetic pads are ready to be packaged. This client wants them in bags of 100. The blue light shows the workers the 100 pad cutoff point. To make cotton swabs, the initial web is divided into 4 narrower webs, each weighing about 0.05 of an ounce per yard. Each narrow web travels through a funnel, which transforms its shape from flat to round. Then it coils into a barrel. The swab-making machine then takes cotton strands from 2 barrels at a time, feeding a line of cotton to each end of the stick. Like the cosmetic pads, the amount of cotton per stick varies according to the client's specifications. The stick feeder prepares the sticks. Then, as we see here in slow motion, the machine cuts the cotton strand and rolls a piece onto both ends of the stick simultaneously. Just prior, a heating device melted the tips of the plastic sticks so the cotton would adhere. With wood or cardboard sticks, they glue the cotton on. The finished swabs are sprayed with an antibacterial solution. Here's that action in slow motion. Now in real time, 2,000 swabs per minute. Sensors detect any defective swabs and automatically toss them off the production line. If you look closely, every so often you'll see one missing. Finally, a robotic arm grabs the exact number of swabs per box, again determined by the customer's specs, and packages them. The company's lab does spot checks on its swabs to ensure that the antibacterial solution is working and that the products are germ